हेलो एवरीवन। तो कैसे हैं आप लोग? आई एम सिद्धार्थ कुमार झा एंड आई वेलकम यू ऑल टू माय यूट्यूब चैनल स्टडी सिंप्लीफाइड। So in today's machine learning project we are going to build a placement prediction system from scratch using Python and machine learning. So have you ever wondered if we can predict whether a student will get placed based on the factor like CGPA, aptitude score, technical skills, internships, communication skills, and other academic details? So that's exactly what we are going to build in this project. So this project is perfect for beginner because you shall learn the complete machine learning workflow from understanding the data set and pre-processing the data to training multiple machine learning models, comparing their performance, evaluation the result, and finally making prediction on the new student data. So by the end of this video, you shall not only have a fully working placement prediction model, but also understand why a particular algorithm performs better than other and how machine learning is used to solve the real world prediction system. So without wasting any time, let's get started and build our placement prediction system step by step. Okay. So for that, I have to go to my Brave. Okay. Or any browser if you are using, it's okay. You just have to open it and you have to search Google Colab and you have to sign in with your account and then this kind of interface it will come. Okay. So here you have to create a new notebook. Okay. So just you have to wait and it will load the interface where you will code. Okay. So here it loaded the interface and here you can see I can write my code. So before writing the code, I have to I have to upload my dataset. Okay. So first of all, just rename the file. So we will rename it like placement prediction system. Okay, and we'll hit enter. So now I will upload my dataset over here. So placement data, I'll upload it dataset. Okay. So now we will start importing all the libraries and then we will perform the operation on the dataset and will so on and will try to create our model. So if you need dataset link, so just mail me in my mail ID जो कि है सिद्धार्थ झा 140804 ओके। तो सिर्फ जो है तुम लोग हमको मैसेज करना डेटा सेट के लिए। इफ यू नीड द कोड लिंक डोंट मेल मी एनी। ओके, बिकॉज आई वांट you just code along with me so that you feel confident in machine learning. ओके, सो चलो स्टार्ट करते हैं। सो फर्स्ट ऑफ ऑल हमको क्या करना होता है, डेटा सेट इंपोर्ट करना होता है। ठीक है, तो डेटा सेट हम लोगों ने ऑलरेडी अपलोड कर दिया। सो अब हम लोग क्या करेंगे, बेसिक लाइब्रेरीज वी विल इंपोर्ट। So for data manipulation, for data manipulation, we will import NumPy and pandas. So we will write like import NumPy as NP and import pandas as PD. ओके, सो अब हम लोगों ने numpy और pandas इंपोर्ट कर लिया। तो हमने आपको पिछले वीडियो में ही बताया था numpy, why we are using numpy, just for numerical what, numerical operation, to perform the numerical operation on our data set। चलो ठीक है। एंड pandas जो हम लोग यूज करते हैं टू रीड द CSV फाइल। ओके, चलो ना, नेक्स्ट वन। So we will just run this. So we'll move further and we'll import library for the data visualization. So this library is for data visualization. तो हम लोग डेटा विजुअलाइजेशन के लिए कौन कौन सा लाइब्रेरी इंपोर्ट किए थे, इफ यू हैव रिमेम्बर, इन द लास्ट प्रोजेक्ट। तो हम लोगों ने इंपोर्ट किया था मैटप्लॉटलिब एंड सीबॉन। तो सेम लाइब्रेरी हम लोग यहाँ भी इंपोर्ट करेंगे। सो वी हैव टू राइट इट लाइक इंपोर्ट मैटप्लॉटलिब dot pyplot as plt. Okay. So the next one is Seaborn. So we have to write like import Seaborn as SNS. So हम लोग इसको डेटा विजुअलाइजेशन के लिए यूज करते हैं, जो लाइक इन आर फर्दर इफ वी हैव टू नीड टू प्लॉट ग्राफ or any comparison of data we need to do. So there we can use these two libraries. Okay. So now we will move further and we'll import the machine learning utilities. Okay. So here we will import machine learning utility. Okay. So machine learning utilities में हमारा क्या आता है? 10 test split and label encoder and standard scalar. So चलो, हम I have already told you like why we are using 10 test split. If you have remember, then just comment it down. So हम लोग लिखेंगे कि हम how we are writing it. So we are writing like from scalar dot model selection import 10 test split. Okay. So 10 test split we are using to split our data set into training part and testing part. So next we will write like from scalar dot pre-processing import label encoder label encoder comma standard scalar. Okay, so in the last video also only I have explained you what is label encoder. So if you don't have remember, you no need to worry, now I am going to explain. So हमारे डेटा सेट में कुछ ऐसा कॉलम भी होता है ना, जो कि ऑब्जेक्ट फॉर्म में होता है या टेक्स्ट फॉर्म में होता है. So to convert text data or object data into numerical value, we are using label encoder. Okay, and standard scalar. So you just tell me what is a standard scalar if you have remember. Okay, so a standard scalar is a pre-processing technique in machine learning that scale numerical features so that they have mean of 0 and a standard deviation of 1. So in this, it is a part of pre-processing model in scikit-learn. Okay, so the formula, if you have remember, we have learned in the machine learning full course. So z is equal to x minus mu by sigma. So x is your original value, mu is, it means mean of the features. Okay, and sigma is the standard deviation of the feature, and z, which is your scaled value. Okay, so now we'll run this. So the next one, we will import the machine learning models. All the model we will import, like your logistic regression, decision tree, random forest, k nearest, SVC, Gaussian NB, and all. Okay. So here we will import machine learning model. So machine learning model में हम लोग कहाँ से import करते हैं? sklearn से ही, ठीक है. So from sklearn dot linear model import what logistic regression. तो आप लोग को ये क्वेश्चन जरूर आया होगा कि why we are using logistic regression here, why not linear regression. सो चलिए हम एक सिंपल सा आपको एग्जांपल देते हैं एंड दिस एग्जांपल विल clear you the doubt. So in the last video, we are predicting the math score of a student. So it is a continuous value. मतलब क्या हुआ कि अगर हमारा मैथ स्कोर 55.5 आता है या फिर कुछ भी आता है, फ्लोटिंग नंबर में भी आता है, तो इट इज अ व्हाट, वो जो है वैल्यू सही होगा. लेकिन here we are predicting the here we are not predicting anything, we are classifying it. Okay, so like there are two class in which we have to classify whether the student is placed or not. So for that the best is logistic regression. I hope this is okay. So for that I am using logistic regression here. ठीक है, समझ में आ गया. चलो नेक्स्ट बढ़ते हैं. तो नेक्स्ट मॉडल हम लोग यूज करेंगे डिसीजन ट्री. सो हम लोग कैसे इंपोर्ट करेंगे? सो फ्रॉम sklearn डॉट ट्री इंपोर्ट. क्या इंपोर्ट करना है हमको? डिसीजन ट्री क्लासिफायर. ओके, सो द नेक्स्ट वन इज रैंडम फॉरेस्ट क्लासिफायर. तो हम लोग इसको कैसे इंपोर्ट करते हैं? तो फ्रॉम sklearn फ्रॉम sklearn ओ सॉरी sklearn फ्रॉम sklearn डॉट ensemble import random forest classifier. Okay, so the next one is k k neighbors. तो हम लोग उसको कैसे इंपोर्ट करेंगे? सो फ्रॉम sklearn डॉट नेबर्स इंपोर्ट. क्या इंपोर्ट करना है हमको? के नेबर्स क्लासिफायर. ओके, तो के नेबर्स क्लासिफायर. So the next one, we will import SVC. So how we will import? So from sklearn dot svc import. ओ गलती लिख दी, svm import svc. ठीक है. So now the next one is your Gaussian and B. Okay. So from sklearn dot naive bias import Gaussian and B. ठीक है. तो here we have import all the machine learning model. So just try to run this. So here you can see the green tick button. It means the all model is loaded successful. Okay. So now हम लोगों ने मॉडल इंपोर्ट कर लिया है. तो अब हम लोग क्या करेंगे? फॉर इवेल्युएटिंग आवर मॉडल, सो वी विल import some libraries. Okay, so for what purpose? Model evaluation. So for model evaluation, we will import matrix. Okay, so we will write like from sklearn dot matrix import. What we will import? Accuracy score, comma. The next one is your precision score. Precision score, comma. The next thing you need, which is recall. And the next one is your f1 score, and the next one is the confusion matrix, and the last one is your classification report. Okay, So just we will run this. So the next one, we will import the hyperparameter tuning. Okay. So for hyperparameter tuning, we will import grid search CV. Okay. So we will write like from sklearn dot model selection import grid search CV. Okay. So till here we have imported maximum number of libraries. Just two libraries is left. So what are tools for saving our model and ignore all the warnings इन फ्यूचर। हाँ चलो, आपको पता होगा ना कि जब भी हम कुछ कुछ रन कराते हैं, कभी हम कोड लिखते हैं तो कुछ कुछ वार्निंग आता है। ठीक है, तो उसको रिमूव करने के लिए हम लोग पहले ही लाइब्रेरी इंपोर्ट कर लेते हैं विच विल रिमूव ऑल द लाइब्रेरीज, ऑल द वार्निंग्स। ओके, तो we first to save our model we will write like import job lead। ठीक है, तो ये क्या करेगा, हमारा मॉडल सेव करने में यूज होता है। एंड द लास्ट वन we will import warnings to ignore the warning, so we will write like import warning। Okay, and we will just filter the warnings, so warning dot filter warnings, and here we'll give ignore। So just run this। So now we are done with the importing the libraries। So importing all the libraries required for data analysis, visualization, model building, evaluation, and saving the trained model। So why we are doing it? So these library provide built-in function that make the machine learning workflow easier and more efficient. Okay, so I hope this part is clear for you guys. So you can see all the libraries we have imported here. Okay. So now, moving further, so now we will load the data set and understand the data. Okay. So for that, uh, first of all, we have to load the data set. So we will write like df is equal to pd dot read csv, pd dot read csv, and here we will give the file name of our data set. So what its name? Placement data dot csv। Okay, so we will just copy it and we'll paste it over here dot csv। Okay, so now we will print dataset loaded successfully. So we will print dataset loaded successfully। So इसका क्या मतलब हुआ कि हमारा पांडा जो है वो डेटा सेट हमारा रीड कर रहा है सीएसवी फाइल। तो वो रीड कैसे कर पा रहा है, हमारा डेटा सेट लोड हुआ है तभी ये रीड कर पा रहा है। तो हमारा सक्सेसफुली लोड हो चुका है डेटा, इट मीन्स। ओके, सो नाउ विल मूव फर्दर। So now we will display the first five record। Okay, so we will display first five record। So how we are going to do that? So for that there is the keyword। So we have to write like df the data frame which we have built dot head। Okay, so ये क्या करेगा? It will give you the first five record of your data set। ठीक है, तो देखो यहाँ पे तुम्हारा सारा डेटा आ गया। स्टूडेंट आईडी, सीजीपीए, इंटर्नशिप, प्रोजेक्ट वर्क, वर्कशॉप और सर्टिफिकेशन, एप्टीट्यूड test score, like that. All the data comes here. So first five record is here. So फर्स्ट फाइव रिकॉर्ड हमको कौन देता है? df डॉट हेड. ओके, ये पूछ सकता है आपसे इंटरव्यू में कि अगर हमारे पास कोई डेटा सेट है और इफ यू वांट टू प्रिंट फर्स्ट फाइव डेटा सेट, फर्स्ट फाइव रिकॉर्ड, सो हम लोग कैसे करेंगे? तो यू हैव टू टेल df डॉट हेड से. ठीक है. सो नाउ वी विल चेक द शेप ऑफ आवर डेटा सेट. ओके, तो कैसे चेक करते हैं? तो वी हैव टू राइट लाइक प्रिंट डेटा सेट शेप. तो डेटा सेट का शेप जो है हम लोग कैसे निकालते हैं? इसके लिए क्या कीवर्ड है? df डॉट शेप. Okay, so just we will run this. So it will give you the shape of your data set. So it means 1000 row and 12 column are there in our data set. So just count it for your confirmation. The first one is your student ID, second CGPA, third internship, fourth project, five workshop or certification, six aptitude scores, seven soft skill, eight extracurricular, nine placement training, 10th SSC marks, HSC marks 11, and placement status 12. So here you can see there are 1000 row and 12 column. Okay, so let's move further. So now we will display the dataset information. Okay, so we will write like df.info. So ये क्या करता है? So it will give you the overall information of our dataset, like the range index. Our index range is 1000 entries, and it is from 0 to 3, 4 times 9. Okay, and it will give you there are total 12 columns in our dataset and all the column name, and is there any null value or not, and its count and data type. Okay, चलो अब इसको समझते हैं क्या है ये. So first is student ID. So not null means 10,000. इसका मतलब क्या हुआ कि null जो है वो जीरो है, and its data type is integer. Okay, and in the next one it is CGPA. CGPA में दिया हुआ है कि 1000 नॉन नल वैल्यू है, और इसका डेटा टाइप क्या है? फ्लोट 64. तो हम अपने डेटा सेट में देखेंगे ऊपर, यहाँ पे देखो, CGPA. This is your CGPA column. So CGPA, all the values comes in the floating number only. That's why it gives here float 64. Okay, so like that सबका डेटा टाइप दिया हुआ है और कुछ का ऑब्जेक्ट दिया हुआ है, एक्स्ट्रा करिकुलर एक्टिविटी. तो यहाँ पे एक्स्ट्रा करिकुलर एक्टिविटी में देखेंगे ऑब्जेक्ट है, yes no like that. Okay, so it treated as object. Okay, so now we'll move further, and we'll see the statistical summary of our data set. ठीक है, तो स्टेटिस्टिकल समरी कैसे देखते हैं? df डॉट डिस्क्राइब से. तो df डॉट डिस्क्राइब. तो ये क्या करेगा? इट विल गिव यू द statistical summary of our data set. So it generating the summary statistics for the numerical columns. And why we are doing it now? Because to understand the distribution and range of our numerical value. Okay, so you can see the count. Count is given 10,000. Okay, and CGPA count is 10,000. All the columns count is 10,000. Okay, row count is 10,000, and its mean it's given like 5,000.5, and its CGPA. So mean means average. Average CGPA is 7.69. Okay, so like that it calculated all the statistical value like your standard, mean, and 25%, 50%, 75%, and 100%, and it uh, it give you here. Okay, so now we'll move further. So it's time to check, is there any missing value or not in our data set. So already we have get an idea that there is no null value in our data set, क्योंकि हम लोग यहाँ पे देखो टोटल हमारा क्या बोल रहा है, 10,000 एंट्रीज, और नॉट नल में क्या बोला, 10,000 एंट्रीज विच इज नॉट नल इन ऑल द कॉलम्स। तो हमारा और वैसे ही पता लग गया कि कोई भी नल वैल्यू नहीं है, बट ये एक प्रथा है तो हम लोग कर ले रहे हैं। तो वी विल राइट लाइक df डॉट इज नल। ओके, सो इट विल गिव यू true, true, false, 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 false. So in everywhere you can only see false, 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 false. तो जहाँ पे भी नल होगा वहाँ, जहाँ पे भी नॉट नल होगा वहाँ पे ये फॉल्स देगा, और जहाँ पे नल होगा वहाँ पे ट्रू देगा। तो इतना हमको पूरा डेटा सेट में देखने गए तब तो हो ही गया। तो वी विल राइट लाइक हियर डॉट सम। तो ये क्या करेगा, सबको ऐड करके हमको दे देगा। ठीक है, तो यहाँ पे देखो स्टूडेंट आईडी में जीरो, सीजीपीए में जीरो, इंटर्नशिप में जीरो, सब में जीरो आ रहा है। ठीक है, इट मीन्स आवर डेटा सेट इज ready to train our model. ठीक है, so now we'll move further, and now we will check, is there any duplicate records are there in our data set or not. Okay, so for that we will write like print duplicate, print duplicate rows. Okay, so duplicate rows हम लोग कैसे पता करेंगे, any idea? For that it is like df dot duplicated. Okay, so now we will run this. सो यहाँ पे देखो ये फॉल्स 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 सब में यहाँ पे फॉल्स दे रहा है, तो हमको जो है ऐसा करना है, डॉट सम कर देंगे। अब ये ढंग से देगा, तो डुप्लीकेटेड रोज इज जीरो। ठीक है, देयर इज जीरो डुप्लीकेट रोज। सो नाउ वी विल मूव फर्दर एंड वी विल रिमूव द स्टूडेंट आईडी कॉलम। ओके, सो हम लोग क्यों कर रहे हैं ये भी बताएंगे पहले। तो सबसे पहले हम लोग रिमूव करके देखते हैं कैसे रिमूव किया जाता है। तो हियर वी विल रिमूव स्टूडेंट आईडी कॉलम। तो for that we have to write like tf dot drop। क्या हमको ड्रॉप करना है, स्टूडेंट आईडी, स्टूडेंट आईडी। ओके, इसको सेमीकोलन के अंदर डालना होता है, कॉमा, इसका एक्सिस क्या है, एक्सिस इज इक्वल टू वन, कॉमा, इन प्लेस इज इक्वल टू ट्रू। ओके, एंड अगर ये हमारा जो है ड्रॉप हो गया तो वी विल प्रिंट स्टूडेंट आईडी कॉलम रिमूव सक्सेसफुली। ओके, तो वी विल प्रिंट स्टूडेंट आईडी कॉलम रिमूव सक्सेसफुली। ठीक है, तो जस्ट इसको रन करो। तो यहाँ पे देखो स्टूडेंट आईडी कॉलम रिमूव सक्सेसफुली। तो इसका मतलब हुआ कि हमारा जो ये टेबल था, हमारा जो ये रिकॉर्ड था, इसमें से स्टूडेंट आईडी जो है ये जो है रिमूव हो गया। अब एक बात बताओ कि हमको प्रिडिक्ट करना है कि बच्चा प्लेस हुआ है कि नहीं, तो वहां पे हम स्टूडेंट आईडी का क्या करेंगे, अचार डालेंगे, क्योंकि हमको तो चाहिए सीजीपीए, इंटर्नशिप प्रोजेक्ट देखना है कि वो बनाए कि नहीं, उसका सॉफ्ट स्किल रेटिंग कितना है, ये सब तुमको देखना है। स्टूडेंट आईडी से हमको क्या करना है, कुछ नहीं। इसलिए वी हैव रिमूव दैट वन। ओके, सो दिस इज कॉल्ड आउटलायर्स। ओके, सो हियर वी हैव रिमूव दैट। सो अब हम लोग वेरीफाई करेंगे कि ये हमारे डेटा सेट से रिमूव हुआ है कि नहीं। तो फॉर दैट वी विल राइट लाइक df डॉट हेड। तो हेड क्या करता है, हमको पांच फर्स्ट फाइव प्रिंट करा के देता है रिकॉर्ड। तो यहाँ से देखो कि हमारा जो है यहाँ पे स्टार्टिंग में मेरा स्टूडेंट आईडी आ रहा था जो कि अब रिमूव हो चुका है। अब हमारा सीजीपीए से स्टार्ट हो रहा है। ओके, सो नाउ we all done. So now we will go the next part, which is exploratory data analysis, which is EDA. Okay, so from here we are just let me print it for your reference when you are making your project. So we will write like SNS dot set style underscore we will give white grid white grid, and then we will write like print EDA started. So we will just run this. So यहाँ से हमको पता लगेगा कि यहाँ से हम लोग EDA अपना स्टार्ट कर रहे हैं. So first of all, what we are doing? So we are setting the visualization style. Okay. So here you can see. Here we have set our visualization style, which is white grid. And the next one. So why we are setting it? Okay. So a consistent plotting style makes a graph clean and easier to interrupt. Okay, so now we'll move further and we will start the EDA. So here we will do the placement status distribution. Placement status distribution. तो यहाँ पे हम लोग ग्राफ प्लॉट करेंगे। ठीक है, तो हम लोग कैसे करते हैं? तो वी हैव टू राइट लाइक plot dot figure, and we have to assign the figure size. So we will give like fig size is equal to 6 comma 5. 6 comma 5. Just to clarify, is there any error? This, hold a second. Okay, so error कुछ नहीं है. So now next we will write sns dot count plot. Okay, and now we will give the x-axis. So in the x is equal to what will be our x? So placement status, comma, data is equal to data frame, data is equal to df, comma, related is equal to set to. Okay, related is equal to related. ओके, कुछ गलत हो रहा है इसमें. Set to, set to. Okay, so now we will give the title. So how we are giving the title? So plot.title. So हम लोग टाइटल क्या देना चाहते हैं? प्लेसमेंट स्टेटस डिस्ट्रीब्यूशन. ओके, सो हियर हम लोगों ने एक बार लिख ही लिया तो बार बार क्यों ही लिखना. इसको कॉपी करो, यहाँ पे पेस्ट करो. ओके, अब हमारा plot.x लेबल. ओके, तो एक्स लेबल में हम लोग क्या देंगे? प्लेसमेंट स्टेटस. ओके, प्लेसमेंट स्टेटस एंड नेक्स्ट हम लोग प्लॉट डॉट वाई लेबल, और वाई लेबल में हम लोग क्या देंगे, नंबर ऑफ स्टूडेंट्स, नंबर ऑफ स्टूडेंट्स, नंबर ऑफ स्टूडेंट्स। तो अब हम लोग क्या करेंगे, प्लॉट डॉट शो। ठीक है, तो उसको जस्ट रन करो, देखो हमारा ग्राफ बन के आता है कि नहीं। या तो यहाँ से देख सकते हो आप कि ये हमारा ग्राफ इज रेडी। ओके, तो थोड़ा मैं जूम आउट कर दे रहा हूँ ताकि क्लियर दिखे। ये देखो, तो टोटल 5000 plus student are placed, not placed, and 4000 something people are placed. Okay, so from this graph, we are able to analyze how many people are placed and not. Okay, so now we will plot the next one. So we will uh, print the placement percentage, like how many people percentage is placed and not placed. So for that, how we are writing the code. So we will write like placement underscore percentage, percentage is equal to df, और यहाँ पे क्या देंगे, हमारा प्लेसमेंट स्टेटस। ओके, प्लेसमेंट स्टेटस। ओके, कॉमा, the next one, placement status dot, sorry, values underscore count, counts, एंड यहाँ पे हम लोग देंगे normalize is equal to true, normalize, normalize is equal to true into 100. Okay, and after that we will print, here we will print placement percentage, placement percentage. So why error is here, df placement dot values count, just run this and see whether we are, no error is there. So you can see placement percentage status. So total not placed student is 58.03 and placed student is 41.97%. Okay, so now we will move further and we will see the GPA, CGPA distribution. Okay, so just we will plot the graph for that also. So how we will write, the same as we have written for the placement status distribution, same we will write for the GPA distribution also. Okay, so here we are plotting the graph for the CGPA, CGPA distribution, distribution. So first of all, we will assign the figure size. So we will write like plot dot figure size, figure. Now we will give the figure size is equal to 8 comma 5, 8 comma 5. Okay, and now here we want to plot the histogram plot. So we will write like sns dot hist plot. Okay, and on what data we want to plot. So CGP. Okay, so we'll give the df and CGP, comma, we will give the beans is equal to 20. Beans is equal to 20. 20, I think it will enough. And we will give the KD is equal to true, comma, color is equal to any color you can assign. So I just want to give the blue color. Okay. So now we will give the title. So what should be our title? So we will give like plot dot title. So title will be GPA distribution. Okay, so we will just copy this and we'll paste it here, GPA distribution, and now we will just plot it. So plt dot show. So just run this. So now it will give you the CGPA distribution graph. Okay, so why it's taking much time? Just hold a second. It will plot the graph. Okay. Okay. So here you can see it has plotted the graph. So what means by beans is equal to 20? Okay. So beans is equal to 20 means there should be 20 this line. You are seeing now this count is 20. Okay, you can count it up as well. Okay. So now we'll move further and we'll draw the graph for the CGPA versus placement status. Okay. So why we are plotting this all graph? Just to understand the data very carefully, and we can understand it properly, like what is our data and how the data is related to each other. Okay. So here we are plotting for the CGPA versus placement status. Okay. So how? So first of all, we have to assign. So we will write the same line. So okay, and the next line. In here we will try to plot box plot. Okay, so SNS dot box plot. Okay, and here we will give the value. So x is equal to what? What will be our x value? X is equal to placement status. Okay, so placement status, and y value will be y is equal to CGPA. Okay, and now we will give from where we are taking the data. Data is equal to data frame which we have built, and plate is equal to set to. Okay, so now I will assign the title. So we will write like plot dot title. We'll give the title CGPA versus placement. Okay, and now we will write like plot dot show. So just we will run this. So यहाँ पे हम लोग को CGPA वर्सेस ये क्या, अच्छा सॉरी सॉरी, सेट टू होगा ना, सेट टू। तो ये जो है हम लोग का क्या करेगा, सीजीपीए वर्सेस प्लेसमेंट स्टेटस शो करेगा कि कितना बच्चों का सीजीपीए कितना था और उसमें से कितना बच्चा प्लेस हुआ है, किस किसके किसके बीच में हमारा सीजीपीए रेंज कर रहा था और उसमें से कितना बच्चों का प्लेसमेंट हुआ है। ओके, सो कंपेयरिंग सीजीपीए फॉर प्लेस एंड नॉट प्लेस स्टूडेंट। ओके, so why we are doing it? To see whether CGPA is influencing our placement or not. Okay, so here you can see the below 8, all the student whose CGPA is below 8 is not placed, and whose CGPA is almost 7.75 to 8.5, below 8.5, those students are only placed. Okay, so from this graph I can able to observe this. Okay, so now we'll move further and we'll draw the graph for the aptitude score versus placement. So the same thing I will copy and paste. I will copy and paste it over here. And here we are doing for the aptitude score and aptitude score versus placement. ओके, सो यहाँ पे हम लोग को क्या देना होगा? प्लेसमेंट स्टेटस, एंड यहाँ पे हमको एप्टीट्यूड स्कोर, एप्टीट्यूड टेस्ट स्कोर. ओके, and the data is equal to df, and plated is equal to set to, and here we will change the title. So title will be our aptitude score versus placement. So just we will change it and just run this. Okay, so here you can see the aptitude score versus the placement. So I hope you can able to visualize the aptitude marks and the placement status, and let me zoom it. Wait. हाँ, अब अच्छे से क्लियर दिखाई दे रहा होगा ना, पूरा एक फ्रेम में. तो यहाँ पे आप देखो एप्टीट्यूड स्कोर वर्सेस प्लेसमेंट स्टेटस. तो नॉट प्लेस स्टूडेंट जितना भी है सबका एप्टीट्यूड मार्क्स कम है, और जो भी प्लेस बच्चा है उसका एप्टीट्यूड मार्क्स हाई है. इसका मतलब क्या हुआ कि एप्टीट्यूड मार्क्स जो है हमारा इन्फ्लुएंस कर रहा है प्लेसमेंट में. ठीक है. So now we will move further and we will see the graph for the soft skill rating versus placement. Okay. तो सेम थिंग हम लोग कॉपी पेस्ट करेंगे, and let me reset it, and here we will check for the soft skill versus placement. Okay. So soft skill, soft skill versus placement. So here we will box plot and placement status, and the next one we will give the soft skill rating. So soft skill rating. Okay, so based on the soft skill rating we will try to check whether the soft skill is influencing our placement or not. So just we will run this. So here you can see soft skill also matter for the placement, but here you can see it overlap, means if your soft skill score is 4.7 almost, so and it above, so then you can get the placement easily. So that it means, so these all we can able to verify from the graph. So here we have given set 2, just try for the set 3. Okay, so now you can able to see I have just changed the color. Okay, so now we'll move further and we'll see for the project versus placement. Okay, so the project versus placement. So the same thing we have to do for the project versus placement. So here we will change project versus placement. So how much project is keep importance in your placement. Okay. So we will give here projects, and here we will change it to the set 3 to call one. Okay, so cool one, and here I will give this thing. It is for the soft skill, not soft skill versus placement. It is your placement versus project. Okay, so just we'll run this. So here you can see if you have two projects, it means you are not going to place. If you have more than two projects, then it is influencing your placement, whether you will place or not. So this we can able to observe from this graph. Okay. So here you can see all the non-place students make only two projects and all the place students make more than two projects. Okay. So now we will check for the internship versus placement. Okay. So now we will check for the internship. So here we will write internship, internship versus placement. So just change this one. So we will give like VIRIDIS. Okay, and here we will, it's nothing but just the color of your plotting. Okay, so here we will change it with the internship versus placement. So just you can say minimum you have to do one internship, then only you can get place. And if you have two, then it is quite good, but minimum one internship is required. Okay, so why it's not coming for this one, for not place student? Let me check whether the internship, yeah, it's correct. Okay, I'll leave it. So you can see minimum you have to do more than one internship for your placement. Okay, so now we will move further and we will see whether you have done the placement training or not. So how much placement training influence your placement? Okay, so now we will check that. So the same code we'll copy and paste it over here. And here we will check for the placement training, placement training versus placement test status. Okay. So our X will be the placement training. So, here I have to change this two line. Our X will be the placement training, the placement training, comma, and HUE is equal to placement status. Okay, placement status. So we will just run this. Uh, just a second. PLACEMENT STATUS. What's this song? Wait. We'll just copy this and we'll paste it. Now, now also it's giving error. Why? Let me check. Okay, I forgot the comma here. Let me just run this. Okay, so here you can see The place and not place. No. Okay, I think there is some error here. Let me just re-verify it. SNS dot. Oh, here we have to do the count plot. Then only it will able to count, na? Count plot. Okay. And x is equal to itna, y is equal to this one. And we have to change the title also. Placement training versus placement status. And now we will just run this again. Yeah. So now I think you are able to see the placement training. Total almost 2000, more than 2000 student has done, and it is not placed. And here you can see what is this one. Your saffron color represent the placed student, and this one represent your non-placed student. Okay, so from here, I think you are able to see the total number of place and non-place student based on the placement training. Okay, so now we'll move further, and here we will see the extracurricular activity versus your placement. Okay, so we will just copy this. We will just copy this, and here we will check for the extracurricular activity. So ex extracurricular activity versus your placement. Okay. So here also we will have to do the count plot only, and here we will change the name and we will give the extra curricular activities. What happened? Extracurricular activity. Okay, comma placement status, and here I will change the title. So how the extracurricular activity affects your placement status. Okay. So total 3,500, more than 3,500 people has done the extracurricular activity and they are placed. Okay, so from this, I think you are able to visualize it. Okay, so now we will move further, and now we will create a correlation heat map. Okay, so here we will create correlation correlation heat map. Okay, so here we will plot, we will write like plot dot figure. Okay, and we will give the figure size. Figure size is equal to 10 comma 8. Okay, let's make it little bit bigger. So next we will give the correlation is equal to correlation is equal to df dot core of numeric only numeric only is equal to true. Okay, and now we will give the SNS dot heat map histogram plot heat map we are plotting. So we will give like SNS dot heat map, and in bracket we will give the value. So correlation, comma, and not is equal to true, comma, CMAP is equal to call warm. So cool warm, comma, we will give like FMT is equal to zero point 0.2F. Okay, so we will see what it means. First, we will run this 0.2F, and after that, we will give the title and we will plot it. So we will write like plot dot title, and here we will give the correlation heat map. Correlation heat map. Okay, and now we will write like plot dot show. तो ये क्या करेगा, हमारा प्लॉट करेगा एक हीट मैप, फिर हम बताते हैं कि ये होता क्या है. So first of all, why we are doing this? So for visualizing the correlation between the numerical features. Okay. So to identify which feature are strongly related to each other and it may influence the placement prediction. Okay, so from here you can see your CGPA and your internship. Your CGPA is high, and if you have done the internship, then it can influence your prediction by 0.28%. Okay. And if you have done more number of projects, and if your soft skill rating is good, then if there are 0.45% chance that you will get the placement. So this is how we are identifying the correlation heat map. Okay. So this part is done. So now we will move further for the data pre-processing. Okay. So now we will move further and will this is part 4. Here what we will do? We will do the data pre-processing. So data pre-processing. Okay. तो चलो अब हम लोग डेटा प्री प्रोसेसिंग करते हैं. बहुत लंबा हो रहा है वीडियो, बट ध्यान से सुनना. इट विल take now I think 1.5 hour more, 1 hour, 1 hour. Okay. So 1 घंटा का और होगा, और ध्यान से सुनना, और जैसे जैसे कर रहे हैं बोर मत होना, लिखते जाना कोड, ताकि तुम लोग सेम टू सेम प्रोजेक्ट अपने पास भी बना सको, एंड इट विल गिव यू द मोटिवेशन ऑल्सो, लाइक या टुडे आई हैव डन वन प्रोजेक्ट, लाइक दैट. ओके. सो चलो बनाते हैं. So now we will display the categorical column. Okay, so here we will display what categorical column. Okay, so how we are going to do that? So we will write like categorical underscore columns is equal to df dot select underscore data type. Okay, and we will write include the object also, include object also, dot column. Okay, so now just we will print the categorical columns and its length. Okay, so we will write like print categorical column, and here we will write print categorical columns, and we'll just run this. So all the categorical columns are extracurricular activity, placement training, and placement status. So what it means, it give you, if you will analyze this, it give you all the object part. Here, let me show you. Here you can see extracurricular activity and placement training and your placement status. All are the character or text. So just we have written here all the categorical column which have object. Okay, so identifying all the categorical column in the dataset, and why we are doing this? Because machine learning model cannot work directly with the text data. So we first identify which column need to be converted into the numerical values. Okay, so now we will use the label encoder. Okay, so I hope in the last video where we are building the model for predicting the math score, there only I have discussed this thing, like why we are using the label encoder. So here I'm not going to explain it. So just I will write like label encoder. ओके चलो बता ही देता हूँ तो लेवल इनकोडर करता क्या है ना कि इट विल कन्वर्ट योर टेक्स्ट डेटा इनटू न्यूमेरिकल वैल्यू ओके चलो लेवल इनकोडर is equal to will give label encoder. So here we will use the label encoder and where we have to use so for column in categorical column df of column is equal to label encoder label encoder dot fit transform fit transform label encoder dot fit transform and we will give the df dot df and column. Okay, so now we will print that categorical column encoded successfully. Okay, so we will print categorical column encoded successfully. Okay, so let's run this whether it is done successfully or not. Yeah, here we can see it printed like categorical column encoded successfully. So here we have convert all the categorical value into the numerical value using label encoding. So this machine learning algorithm requires numerical input. So the categorical data must be encoded before training. Okay. So now we will check. So how we are going to check? So we will write like df dot head, and it will give you the first five uh, data of from your data set. So here you can see like all the value which were in the object form, or you can say the text form, is converted into the text part, into the numerical part. So extracurricular activity 0 1 1 1 1 means whether it is no or yes. Okay. So like that we have encoded it. So now we'll move further and we will check the data type. Okay, just we are confirming it. So we will write like df dot d type. Sorry, d types. So here you can see all the value come in the integer. Okay. So here you can see like some of the value comes in the float. So it's okay. It is kind of an integer. So our machine will work on that, but not in the integer part. Okay. So now we will move further and we will separate the features and target. So for that, how we are separating it? So we'll what we are doing here, we'll separate features and target. Okay. So we'll write like x is equal to df dot drop placement status comma x is equal to 1 is equal to 1. So from here I am dropping the placement status and we are putting it into the different data point, and we will write like y is equal to df and placement status. Okay. So now we will print it. So we will print what feature, shape, uh, comma x dot shape, and we will print for the y shape also. So we will write like target shape. So print target shape, comma y dot shape. So we'll just run this. So here we can see the feature shape is 10,000 comma 10 and target shape is 10,000 comma. Why is there any error? There should be some value, I think. df dot placement status y is equal to df placement, and we are printing it. Okay, leave it. So here you can see the feature shape is 10,000 comma 10. Why 10? Because we have dropped the one more value. If you have remembered, then in the starting we have 12 column, and then we have removed the id, student id, then it remain 11, and now I have dropped the what, placement status. So now it's 10. Okay. So now we'll move further and we will give the x dot column. So we will check x dot column. So we will just run this. So here you can see all columns which are available now. So the first one is CGPA, internship, project third, and certification 4, aptitude 5, soft skill 6, extracurricular 7, placement training 8, SSC marks 9, and HSC marks 10. Uh, so there are total 10 columns only now. So to verify which variable will be used to the model for the prediction. Okay. So now we'll move further and we'll do the feature scale. Okay. So here we will do the feature scaling. So we will write like a scalar is equal to standard scalar. Okay. And we will scale it. So x underscore scaled is equal to scalar dot fit transform. We will write scalar dot fit transform on x. Okay. And now we will print it. So we will print your feature scaling completed. Okay. So we will copy it from here only. So we will print feature scaling completed. And just we will run this. So here it shows like feature scaling completed. So here what we are doing. So just we are standardizing all the features value. So what it needs, why we are doing this? So some algorithm perform better when all the features are on a similar scale. Scaling prevents the feature with layer values from dominating the learning process. So just note a point like algorithm decision tree and random forest does not require scaling. Algorithm like logistic regression, KNN and SVM benefits from it. Since we shall compare the multiple models, we shall use the scale features. Okay, so now here we will write like x underscore scaled and we will give the value 5 and just print it. So here you can see we are getting the scaled value. Okay, so it displaying the first 5 scaled record. So why we are doing this? To confirm that the feature scaling has applied successfully on a dataset. Okay, so now the time is to split our dataset. Okay, so how we will split it? So we will write x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test is equal to train test split. And here we will give the value. So x underscore scaled, comma, y, comma, and we will give the test size. Test size is equal to 0.2. It means total 20% of our data will go for the testing and automatically 80% will go under the training part and we will assign the random stage is equal to 42. Okay, and we will just run this. So now it splits our data sets. Okay, so just we will verify it whether the training and testing data set is splitted or not. So we will write here print uh, training features, training features, comma x underscore train dot shape. Okay, so we'll just run this. So training features is 800, 8,000, comma 10. It means total 8,000 data, means 80% of our data is splitted for the training features, or you can say the training part. Okay, so like that, we will print for all the testing features and training labels and testing labels also. So we will write like in the same one, I think I should write. So we will write like print. We will write testing feature, testing features, comma, x underscore test dot shape, and now we will print for the training label, training labels, and we will write here y underscore train dot shape. Okay, and now we will print for the testing labels. Okay, so here we will print what testing label, and y test dot shape. Okay, so just run this. So it will give you the shape of your training and testing labels. Okay, so here you can see the training features are 8,000 comma 10. Testing features is 2,000 comma 10. Training labels is 8,000 and testing level is 2,000. Okay, so now we'll move further, and we will try to uh, build our model. Okay, so here we will train our models. So in one code only, we will train our all models. Okay, so we will write like model is equal to, and in the curly braces, we will use all the models. So what are the models we are going to use? The first one is your logistic regression, tick regression. Okay, so here we will give like logistic regression. Okay, comma. Next one is your decision tree, and here we will give the value, and here we will write decision tree classifier, decision tree classifier, and here we will give the random state is equal to 42. Okay, and next we'll move further, and we'll do for the random forest. Okay, so here we will do for the random forest, and for random forest I have to import write like random forest classifier, and we will give the random state is equal to 42. Random state is equal to 42. Okay, and next we will do for the kn. So for the kn, we will write like kn neighbors classifier. Okay, and for the next model, which is our svm, so we will write like svm, and for this from where we have imported is svc, we will write like svc, and the last one, which is your naive bias, you have to write like naive bias, and here you have to write Gaussian NB. Gaussian NB. Okay, so here we have created a dictionary for all the models. Okay, so now we'll move further. So creating a dictionary contain all the machine learning models. So why we are doing it? To allow us to train and evaluate multiple model using a single loop instead of writing repetitive code. Okay, so now we will check the accuracy score. So we have to write like accuracy score is equal to. So just run this. So it will create an empty dictionary to store the accuracy score. So it helps to compare the performance of all the model later. Okay. So now we will train and evaluate all the models. So we will write like for model name, for model underscore name, comma, model in models, model in models, dot items. Okay. And for model name, comma, model in models, dot items. Okay. And we will write like model dot fit, model dot fit in extend, comma, y train. Okay. And next, we will predict on the test data. So we will write like y underscore predict is equal to model dot predict on our x underscore test data. And now we will calculate the accuracy. So for calculating the accuracy, we will write like accuracy is equal to accuracy score, and on what value we will calculate the accuracy. So y test and y predict. So for y test, comma, y predict. Okay. And now we will store the accuracy. So we will store accuracy in the, so how we are going to do that. So here we have created the empty dictionary. Okay. So there only we will push that data. So we will write like accuracy score, accuracy scores, and model name, model underscore name is equal to accuracy. Okay. And now I am going to print that. So we will write like print model name, model underscore name, and accuracy. And its value will come from where? The accuracy list, accuracy dictionary. Okay. So we will write accuracy, and we will make sure that it comes from the four floating point. Okay. So we will just run this. So here I think we are getting some error. Model is not defined. Model. Oh, here I have written model now. So just run this. Okay, here DICT dict object is not callable. What? This where is this error? Mm, accuracy is equal to accuracy score y test comma y predict. I think I have done some mistake over here. Let me just check this. So for model name, model in models dot model dot models items. Okay, and model dot fit x10 and y10, and the y underscore predict is equal to model dot predict x test, and here accuracy is equal to accuracy underscore score and y test comma y predict. Okay, so why the error is coming here? Next step, explain error. Continue, and we'll check why this error is coming. Dict is not callable. Research code function in scikit-learn was overwritten by dictionary in the same name. So I accuracy scores. So now let's run this. Attribute error. Logistic regression object not logistic regression. It's there. What the problem? Logistic regression, decision tree, random forest, k nearest neighbor, SPC, and Gaussian NB. So for model name in just I will write a give me correct code. Let's see what it will give. I think this is correct only, no? For model name, comma model name, except all and run. After that, also why this problem is coming. Next is accuracy is equal to accuracy score. Uh, wait. Let me verify it from the starting only. Okay, model is equal to logistic regression. Logistic regression. Okay, decision tree classifier. I think this one is okay. No problem here. So now we'll move further, and we have created accuracy scores. Okay, now let's run this. After I am getting error. What the heck is this, bro? Just hold a second. Let me verify it. For model, accuracy is equal to accuracy score. Now just run this. Uh, Let me clear this line. Why I am getting error? I'm not able to identify this. Scalar dot matrix. No, 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 no. I think I have destroyed this thing. For model in just a second. Accuracy score. I think no need of this one. Okay. And here, let me check. Name error. Accuracy is not defined. Name error accuracy is not defined. Make it correct. Yeah. So here, you can see I have figured out the problem, and here you can see what happened. The logistic regression accuracy is 0.7945, and decision tree accuracy is 0.72. Random forest accuracy is 0.78. So just see carefully, like what we have done here. Okay. So and just here, I think in this part, I have forgot to write ml underscore model dot predict. Okay, so I think from this line only I was getting error. So I have fixed that one. So now let's move further. So now what we will do, we will display the accuracy score. Okay, so for that, we have to write like accuracy accuracy underscore df is equal to pd dot data frame. Okay, and here I will give the model and its accuracy score. Okay, accuracy accuracy underscore score dot key. Okay, and for the accuracy, here we will write accuracy scores dot value. Okay, so now I will just write accuracy underscore df. Now we will sort that in the ascending order. Accuracy underscore df dot sort values. Okay, so now just we will print this models. Accuracy score dot key and plain error invalid syntax. Where it's invalid. Okay, accuracy. Now here you can see I have corrected that. Accuracy underscore df dot sort value by accuracy, comma, ascending order is equal to false and in place is equal to true. Okay, so what we are doing? So we are just creating a table of model accuracy. So to easily compare the performance of all the models. Okay, so now we will select the best model. Okay, so best model. So for that we will write like best underscore model is equal to max maximum of accuracy score, maximum of accuracy score, comma, key is equal to accuracy score dot get, and then we will print the best model. Okay, so we will print best model, comma, best model, and we will print the accuracy also. So we will just print uh, the best accuracy is equal to accuracy score, whose the model name also. So just see here, it will give the output as best model is your logistic regression, and its accuracy is 0.79. Okay, it means 79.45% is the accuracy of the logistic regression model. So now the time is to compare the accuracy in the chart form. So for that, here we will write plot figure, sorry, plot dot figure, and we will give the figure size, figure figure size is equal to 10 comma 6, and we will use the SNS dot bar plot, and here we will give the x and y. Okay, and we will give the title also. X title is your model accuracy, and y is your accuracy, and then we will print it. So here we will give like machine learning models and accuracy. Okay, and rotation is equal to, we will give 20. 45 will be too much, so we will give 20. So here I will write like plot dot show. Okay, so here you can see like we have plotted the accuracy for all the models in the graph form. So from here you can see the highest accuracy is the logistic regression. Okay, it's zero point 0.7. It's more than zero point 0.7 and near to 8.8. So here you can see the accuracy is 0.79. So here from the graph also you can clarify it. Okay, so this part is clear. So now we will move further for the model evaluation part. Okay, so now we have trained our model. So it's time to evaluate it based on the evaluation matrix. So for that, we will write evaluation result. Evaluation result is equal to, we will create a dictionary. We will create a list. Okay, so just run this. So now here we will evaluate all the models. Okay, so just a second. So we will write for model underscore name in model underscore name comma model in models dot item, model dot models dot item, and what happening guys, I don't know, models dot item. And next we will write y underscore grid is equal to model dot predict x underscore test, and accuracy score is equal to y underscore test comma y underscore predict. Okay, and the next one is your precision, recall, and f1 score. Okay, accuracy, precision, and f1 score. So we have written for all of that. Now we will store the result. Okay, so how we will store the result? So here we will store the result. So here we will write evaluation dot result dot append. Using the append, we are appending, we are adding it. So model accuracy, precision, recall, and F1 score, we will append it. So just run this. So here we have stored all the result. So in this, we will calculate the evaluation matrix for every trained model. So why it necessary? Because the different metrics measure the different aspects of the model performance, uh, giving a more complete evaluation than accuracy alone. So the next part here we will create the evaluation data frame. Okay, so we will write like evaluation underscore df is equal to pd dot data frame evaluation result. Okay, evaluation result, and just a second. I think my headphone get discharged. Just a second, let me check it. How much percent? Okay, it's 10%. So it will done. Okay. Now we are done with the project. Just a few, I think 10 minutes is more. So we will write like evaluation result. Okay. So evaluation df is equal to evaluation evaluation df dot sort values by accuracy. Okay. And ascending is equal to false. It means it will sort by the descending order, and we will write like evaluation underscore df. Okay, so we will just run this. So here you can see it's given the model and accuracy, precision, recall, and f1 score for all the models. Okay, so now we will move further, and here we will choose the best model. Okay, so we will write like best underscore model underscore name is equal to evaluation dot df dot iloc model is equal to 0. Iloc 0 comma model. Okay, and then we will print the base model base. So here we will print the base model, base performing model based on what? Base model name, based on the base model name. Okay, so we will just copy this and we will paste it over here. So just run this. Name error evaluation is not defined. Defined as evaluation.df. And now we will just run this. So here you can see the base performing model based on this uh, accuracy, precision, recall, and F1 score is our logistic regression. Okay, so why we are doing this? To find the model with the highest accuracy. Okay, so the next step which we will do is we will retrieve the best model. Okay, so how we will do that? So we will write like base underscore model is equal to model, and here we will give the best model name. uh, Best model, what best model name. Okay, and we will write y underscore read is equal to best model dot to predict based on the x test. Okay, so what we are doing? So we are selecting the best model and generating the prediction. Okay, so these prediction will be used to create the confusion matrix and the classification report. So here we will create the confusion matrix. So we will write like hashtag confusion matrix. So we will write like CM is equal to confusion matrix, y test and y predict, and we will plot the figure. Plot dot figure size we have given 8 comma 6. SNS dot heat map, we have given the CM a naught is equal to true, FTM and cam is equal to blue, and C bar is equal to false. Okay, and then we will give that plot dot title is equal to confusion matrix, and X label is predicted label, Y is true label, and we will write like plot dot show. Okay, so just run this. So here you can see you will get a confusion matrix. Okay, based on this value. Okay, so next step, we will do the classification report. Okay, so for that, let me just reset the screen size. So for that, we will write print classification report is based on the y test and y predict. So here it will print the classification report. So here you can see the precision is 0.83, and on the value of 0, recall is this much, this much, this much. So here it give you the table. Okay, so now here what we are doing. So here we are displaying the classification report, and why we are doing it. So it provide the detailed performance metrics for each class, including the precision, recall, and F1 score. Okay, so now we will visualize the evaluation matrix. So here we will visualize the evaluation matrix. Okay, so for that we have to write evaluation underscore df dot set index dot set underscore index model, and we will plot that. Okay, so uh, just give me a second. Evaluation dot set index model evaluation dot plot. Okay, plot dot show. So here we will. So here you can see it give you the accuracy, precision, recall, and F1 score for the logistic regression, naive bias, SMS, all the models which we are using it over here. So now we'll move further, and the last part of the project came. So here we will do the hyperparameter tuning. Okay, so let me check how much is my headphone percentage. It's 5%. So I have to do it very fast. Okay, so hyper hashtag hyper parameter tuning. Okay, so for that we will write the code. So we have to write like underscore grid is equal to, and here we will give the an estimator, and here we have given the max depth, minimum sample split, and mean sample left. Okay, so max depth and mean sample split. Okay, this one I don't think it's required. So now we will search it on the grid. So for that, uh, we will write grid search underscore search based on this estimator. Okay. So what we have written, CV is equal to 5 and underscore job is equal to -1, and where boss is equal to 1. Okay. And just we will print the base, and after that the best score we will print. Okay. So just run this. So here you can see fitting the 5 folds for each of 36 candidates, comma totaling is equal to 180 feet. Okay, so just it will take I think 1 minute to run this. So just hold a second. So तब तक हम लोग नेक्स्ट लाइन कोड लिखते हैं जो हम लोग का नेक्स्ट पार्ट है. So here we will give like best underscore rf is equal to grid underscore search best estimator. Okay, so what it will do. So here we are saving the model, best model. So the best random forest model. So I think best is logistic regression. I think no. So best is logistic regression. Okay, so just we are saving it over here. So this model has the best parameter combination and it will use for the final prediction. Okay, so now I will predict using the tuned model. Okay, so we will write like y underscore predict best RF predict underscore x test and just we will print that. Okay, so what is the accuracy? Okay, so we will print accuracy, comma accuracy score y test and y predict. Okay, so now what we are doing? So we are evaluating the tuned random forest model. Sorry, tuned which model? Logistic regression. Okay, and we are just printing the accuracy score based on the testing and predicting value. So here we are verifying whether hyperparameter tuning has improved the model performance or not. So now we will do the feature importance. So we will write the code for that. So we will write like feature importance is equal to PD data frame, and here we have given the x column, x dot columns, and importance is equal to what? Just a second. Best feature importance. So feature importance. Okay. So we will just print this. So here you can see the feature importance versus your marks. Okay, so all the HSSC marks is influencing your accuracy, influencing your what prediction mode. So here we are calculating the importance of each features. So to understand which features contribute the most placement prediction. Okay, so now we will draw the bar plot over here. So here you can see I have drawn the bar plot and here we are analyzing the performance. Here we are analyzing the importance of all the features. Okay, so now we will next and we will save our models. Okay, so how we are saving it? So we will write like job lib dot dump the best RF comma placement prediction model dot pkl and we'll print that model is saved successfully. So here you can see our model is saved. This one is your saved model. Okay. So now we will move further and here we will save the fitted standard scalar also. So we will write like job lib dot dump scalar and we will write like scalar dot pkl. So here you can see scalar dot pkl model is also saved scale model. Okay, so here we are saving the fitted standard scalar. So why we are doing this? Because feature input data must be scaled in the same way as the training data before making prediction. Okay, so now we will make the real life prediction. Okay, so here we will input the sample student data. Sample student data. So here we will new write like new student is equal to pd dot data frame pd dot data frame and here we will give what all the values like cgpa you will give 8.5 aptitude score, just after CGPA, you will give the internship and a project, and after project, you will give work or certification. After project, you will give work, work, workshop, comma, certification. Okay, so here you will assign the score. So here you will give like 4. Okay, and after that you will give the works, comma, you will give what? Aptitude test score. Aptitude. Uh, okay, it's here only. So after this, you will give the aptitude test score in the same order, which were there. Aptitude. What is there any problem? Dictionary entries must contain key values pair. Okay, my mistake. 4. Workshop aptitude score. After that, soft skill. After that, you will give aptitude score. After that, you will give soft skill. And after that, you will give the SSC marks. So SSC underscore marks. And here you will give the value like 90. And then here you will give the HSSC marks. So HSS, HSSC marks. Here you will give like 87, and then extracurricular activity and placement training. Okay, so oh, like this. Okay, and just run this. So here extracurricular activity. In extracurricular activity, well, okay, I forgot the comma here. Okay, so after this, you will make a prediction. So you just scale the input data. Okay, so here, uh, let me check my mic also first. How much percent? 1%. Okay, so here we have to scale the input data. So we will write like new student scaled and a scalar dot transform new student. This feature means should not match those passed during the system marks and it now value error. So I think here I have done some mistake in the CGPA internship project, workshops and certification, aptitude score, soft skill rating, and SSC marks, SSC marks, HSSC marks, HSSC marks, expectation, and placement training. Okay. So I think this is okay now. Let me explain the error. What error I am getting. So just hold a second. Let's see what error it will give. Value the format name should be matched those were passed during the fit. Okay, just see here. I have given M capital A. Accept and run. So here just run this. So here I think it's correct. So let's check here. I think my mic get off. Okay, no, it's sharp. So just a second. We are just and now we will run this. We are getting error. Okay, I don't know what happening over here. Except training dot fit new student scalar dot transform student reordered. Uh, yeah, here you can see here it came tick mark, so it's correct. So now we'll move further. So now we'll make the prediction. So we'll write like prediction is equal to best RF dot predict new student scaled. Okay, so new student scaled and prediction, and we will write like probability is equal to best RF dot predict new student scaled. Okay, so now we will give prediction if prediction is 0 is equal to 1. It means we have to print prediction is equal to placed is equal to place or else not placed. Okay, so just run this, and now we will write like the placement probability. So we'll write the print f placement probability of getting not placed and placed. Okay, so just uh, okay, sorry, just we will run this. So here you can see that we are getting the prediction. Okay, so for the for this student, uh, this change. Okay, so for this student, whose details I have entered over here, so creating, we are making the prediction for this student. Okay, so here what we are doing. So if the prediction value comes 1, because in the initially I have told you that here we are classifying whether the student is placed or not. So Uh, if it come one, it means the student is placed, otherwise not placed. So here it's giving like the student is placed, and probability of getting placed is 20%, and probability of getting not placed is 21%, and getting placed is 79%. It means there is 79% probability that this student is placed. So this is how our model works. So if you guys like this video, so share it with your friend and don't forget to subscribe my YouTube channel. So see you in the next video. Tab tak ke liye keep learning and keep exploring. Bye bye.